Hello, and welcome to part 2 in the module that talks about patterns and frameworks for service access and communication. In the previous part of this module, we summarized some of the accidental complexities with the C-level socket API. In this part of the module, we're going to describe how the wrapper facade pattern can help to alleviate these accidental complexities. So what's the problem? If we're trying to build a web server or any other kind of networked application, we often have to access various operating system services. Services for communication, both local and remote communication, concurrency, both processes and threads, synchronization, various kinds of memory management, and so on, and file access. The problem here is that programming directly to the low-level operating system interfaces exposed by the OS, written in C usually, is a tedious and error-prone and non-portable ordeal. So how are we going to get around this? We're going to be applying the wrapper facade pattern to avoid having to access these low-level APIs directly. The wrapper facade pattern encapsulates the data and functions provided by the existing C APIs with more concise, more robust, portable, maintainable, and more cohesive object-oriented classes. Take a look at the interface that's shown down here, the structure we've shown. You'll see that rather than accessing the functions directly, which is the classic way we would do things, instead we have our applications, our web server, accessing those functions through a class wrapper facade. And that wrapper facade exposes a number of different methods, and those methods then access the low-level functions, but they do it in a way that won't expose those details and the accidental complexities of using the C-level APIs directly to the application code. If you take a look at the dynamic interactions, if you're a client, if you're a web server, for example, and you invoke an operation on the wrapper facade, then under the hood, it turns around and makes a call to one or more system functions to do its job. And it would typically stash away whatever data types have to be passed to those low-level functions and keep them as part of the private state of the wrapper facade object. At first glance, the structure and dynamics of this pattern look familiar. They look a bit like the bridge pattern. They look a bit like the very other patterns from the Gang of Four book like proxy. But there are some important differences. The main difference is they're typically lighter weight. There's no indirection that's going on as you would do with bridge, and there's no conversion and transformation that's going on with proxy. So you can keep them very thin and lightweight, not adding much overhead. In fact, you can often inline the wrapper facades to make the overhead evaporate altogether. You can take a look at the Post-it 2 book for descriptions about wrapper facade. You can also take a look at the various ACE books for examples of how to do this in ACE, or you can take a look at this paper listed at the bottom of the URL for information about wrapper facades. So let's talk about how we might apply the wrapper facade pattern to JAWS. So what we'll do here is we'll use this for any time we're going to access system programming interfaces. Instead of accessing them directly, we're going to access them through the various wrapper facades defined by the ACE communication environment. And just as one simple example, here's an example of how JAWS might use the ACE thread mutex, which is a wrapper facade around the low-level synchronization mechanisms for mutual exclusion that you'll find on various operating environments. This one illustrates the mapping to Solaris threads. It's easy to do this to map it to POSIX-P threads or Windows threads or various other kinds of mechanisms you might find on real-time operating system environments and so on. In practice, JAWS is going to use lots more stuff that we would find in ACE, all the other wrapper facades for other types of OS services it encapsulates behind an object-oriented programming interface. So what are some of the benefits of using wrapper facade? Well, first and foremost, we can provide a much more type-safe interface. Rather than trying to use these low-level functions and low-level data that are ints or pointers, we can use classes with strongly typed interfaces, which means that a lot of the problems and error conditions just disappear altogether. We can also make things more portable. A wrapper facade is a great layer to also abstract away from operating system diversity and heterogeneity. So you don't have to be beholden to the particular syntactic mechanisms that Windows uses versus Linux or versus VxWorks. You can make those things pluggable and commoditize the operating system layer. Yet another capability you get by using wrapper facades is you end up with more modular and reusable components that can be cohesively integrated together to form higher level units of abstraction by using things like inheritance or parameterized types to build upon the existing capabilities. There are, of course, some limitations with the wrapper facade approach. Anytime you try to provide a portability veneer, something that abstracts away from the particulars of any particular platform or any particular operating system, you have to be careful that you don't reduce the capability and functionality by omitting certain things that aren't available everywhere. For example, there are certain capabilities that you have on some platforms with respect to certain locking mechanisms. And if you try to come up with a wrapper facade that's the intersection of all the portable capabilities in all the operating systems, then certain things by their very nature would be left out. In those cases, you might choose to do some emulation of one synchronization mechanism in terms of other ones that are more portable in order to provide a consistent wrapper facade facility on all the operating environments. Another potential limitation with wrapper facade is performance degradation. If you're not careful and you have large layered calls and indirection in your implementation, then you can take something that looks simple and lightweight and turn it into a heavyweight mechanism, which is one reason why we typically recommend not using patterns like proxy or bridge when you're trying to build abstraction layers, but instead sticking with something lightweight like wrapper facade. Yet another potential problem, programming language and compiler limitations. If your operating environment, if your language doesn't have a way to map conveniently and efficiently to C functions, then wrapper facades may be hard to enable. Fortunately, almost all languages these days have callouts to C, so you can find ways to encapsulate the low-level services behind higher-level objects and class interfaces.